Right. So in this experiment, we are going to discuss about a LDR, light dependent resistor. LDR means light dependent resistor. Based on the intensity of the light, the resistance is varying. So that's why this resistor we call it as a light dependent resistor. Resistance is varying means current is increases or current is decreasing based on the intensity of the light. Clear? So now you able to see the to draw the aim, we have to see to draw the VI characteristic. V means voltage, I means current, VI characteristics of a LDR, light dependent resistor. What is the symbol of the LDR? Here LDR also two terminals are there. This is the resistance, right? Resistance. Now we have to apply the light on the resistor. Light on the resistor. This is the symbol of what? LDR. Symbol of the LDR. This one also we have to show. Like this also we have to show. Right? This is one. This is another one. This is the symbol of the LDR. Now what are the operators of the LDR we have to see. The LDR, this one is the LDR. We are preparing the LDR like this. This is the LDR, structure is LDR. You have to see the LDR one you have to take first one, and the second one we have to see. Two terminals are there. For one terminal we have to connect the one wire, and another terminal I have to connect the another wire. Next 100 ohms resistance you have to take 100 ohms resistance. For the intensity of the voltage, we are different wattage bulbs we are taking. So this wattage bulb is maybe you have to take maybe 40 watts, correct? 40, 100. This one is 100 watts, right? Now you have to take the one more bulb you have to take based on this wattage. How to observe how much wattage is there. That wattage is 60. Here 60 is there, 60 watts, and you have to see this wattage of the bulb is equal to how much wattage is there. This one, right? That wattage is how much? 60, right? 60 and 100 is there. 60 and 100. Clear? So patch cards and everything we have. Now formula you have to see. Formula, the Ohm's law also it is depend on here. V is directly proportional to I, V is equal to R into I, R is equal to V by I. One more formula also is there. R is equal to A into e to the power of minus x. What is A? A is the A and X are constant terms. A and X are constant terms, right? The values of these made with the cadmium sulfide material. This LDR is made with cadmium sulfide material. Which material it is? Cadmium sulfide material. R is the resistance in ohms. R is the resistance in ohms. E is the illumination. What is the unit of the illumination? Lux is the unit of the illumination. Unit of the illumination is lux. Clear? This is the formula. Resistance is varying with the illumination. Resistance is varying with illumination. That is the relation between the resistance and illumination. Now you are able to see the circuit diagram. So this one is LDR symbol, right? This LDR you have to connect. This is the LDR. You have to connect it to one end. You have to connect it to here. Another end you have to connect it to here. These are the two terminals. You have to take this LDR. You have to connect it to one end and another end. So now you able to see the power supply positive. This power supply positive you have to connect it to where we have to connect this power supply positive. You have to connect it to the LDR one end. This power supply positive you are going to connect with the LDR one end. You have to connect. This is the power supply positive. That power supply negative you are going to connect with power supply negative. What is this? This one is the ground. Power supply negative you are going to connect with the ground. This is the power supply negative. Clear? Now you able to see the LDR another end you are going to connect with the LDR another end you are going to connect with 100 ohms resistance. This LDR another end you are going to connect with 100 ohms resistor, right? This is the 100 ohms resistance you have to connect. Next, you take two patch cards. Two patch cards you have to take. So one patch card you have to connect it to this 100 ohms resistance. Another end you have to connect it to here, right? One more patch card, milliammeter negative, you have to connect it to the ground. Where you have to connect? You have to connect it to the ground. Now, so what is there? One voltmeter is left behind. So one voltmeter is there. That voltmeter we have to connect where parallel connection. Voltmeter negative and voltmeter positive. This is the DC voltmeter. So the voltmeter negative, the parallel connection wherever LDRs are there, no. So there you have to connect it. This is the parallel connection. LDR. So LDR one end you have to connect it. LDR next end you have to connect it to this one. LDR next end you have to connect. This is the complete connection. Clear? So after this connection, what observations we have to do here? So based on the observations, you are able to see we are applying the voltage. We are seeing the ammeter current. First, for a dark light, you able to see. For the dark light, you have to see. Take one cloth. So you cover with LDR. So you have to cover with LDR. It is not there, no. So dark light you have. So one cloth you have to take one cloth. Maybe this cloth you have to take. Clear? So this cloth you have to take and you cover with LDR. Now it is completely dark. So once it is dark, so what will happen? Under the dark of the LDR, you apply this, right? So now you wearing this, so 0 volts you have to apply. Maybe you are getting the 0 milliamps. 1 volts you have to apply. 1 volt you have to apply. You are getting that 0 milliamp. 2 volts you have to apply. So 3 volts, 4 volts and 6 volts and up to 15 volts we are applying. How much you have to get? So you are getting the 0 only, because this LDR in the presence of the dark light, unable to give the light only. Clear? Now you able to see in the presence of the room light, you have to apply in the presence of the room light. In the presence of the room light, you have to apply. So presence of the room light you have to apply. What is going to happen once you have to see here? So first 0 volts you have to apply. You are getting the 0, right? So 1 volt you have to apply. 1 volt you have to apply. 1 volt you have to apply. You have to apply the 1 volt. So how much you have to get here once you have to see, right? 1 volt you have to apply here. 1 volt you have to apply. Clear? 1 volt you have to apply. You able to see how much current is coming. That is you have to take it is so right. For 10 volts you are getting 0.2. For 10 volts 0.2 you are getting. For 12 volts 0.4 you have to get it. So sign up to the 15 you have to take. The same way, now in the dark light we are observing the resistance of the LDR, and in the room light we have to observe the illumination of the room light. Now you have to take a 60 watts bulb. 60 watts bulb you have to take. This is the 100 watts bulb. So this bulb is 60, right? 60 watts bulb you have to take, and now you illuminate that one. The 60 watt bulb you have to illuminate. How much? Right. Now the bulb is illuminating. Clear? Once you have to see here. In the presence of the 60 watt bulb, now you incident on this LDR. How much it will come? First you apply 1 volt you have to apply. So 2 volts you have to apply. For 1 volt only you are getting the value. Once you have to take this one. For 1 volt only. You are getting that value. For 4 volts you have to see the 3. For 3 volts you have to take it as. For 9 volts you have to take 1.5. For 8 volts you have to see 2.2. For 9 volts you have to see 3.9. So those values you have to write here. So 1.2, 2.3, 3.9 and so on, the values are coming. Those values you have to write it. Now you take this one, you remove it, and this bulb you have to remove. Now you able to take that bulb is 100 watts bulb you have to take. 100, yeah, this is 100 watts bulb you have to take. Now you, I'm intensity, more illumination. I'm using this more illumination, right? So I'm illuminating on the LDR. Once you have to take, again you have to apply. So that is the intensity of the 100 watts. Now you have to see, for 4 only you are getting the 3. For 6 you have to get the 8. For 7 you have to get 14. For 8 you have to get the 36. Increasing now. So now this is the values are increasing. So those values you have to apply here. So for 100 volts apply. Once you have to take these readings, after taking these readings, you make the plot. Voltage versus current plot, you have to plot it. For the dark light, 0. In terms of the milliamps, I have to take here in terms of the milliamps. Now, so in the room light, some line will come like this, straight line. In the 30 volts bulb, 30 watts bulb, you are getting this one. The 40 and 60 and 100, you have to take, and you take that one. And you make the slopes, you have to find out. The slopes you have to find out. So the reciprocal of the slope you have to identify. So next you calculate the resistance of the dark light and resistance of the room light and resistance of the 60-watt bulb and resistance of the 100-watt bulb you have to observe. Based on these resistances, if dark light is resistance is larger value, if it is room light, some resistance is lower, it will come very low. And if it is light intensity is increases, the resistance value gradually decreases. Clear? So like this way we have to tell about this LDR is depend on the light intensity characteristics. So that's why by illumination of the light on a resistor LDR, so there is a resistance is varying. This experiment we proved by using the VI characteristics. This is the photoelectronic device. This device is photoelectronic device. So by application of the photoelectronic device is LDR. Clear? So this is the experimental setup for finding the LDR. So please share and subscribe and like our YouTube channel and comment. Thank you.